Hey everyone, I'm Robin, and I'm here today representing Avail. I'm a developer at Avail, and Avail is the unification layer for Web3. And I'm going to talk to you about why we are the unification layer, right? Technical difficulty, 1 minute. Yep. And yeah, so Avail the unification layer for Web3, right? So let's take a step back. Let's look at the ecosystem as a whole, right? So Ethereum has been going through this change over the past few years, right? Ethereum has noticed a lot of roll-ups being, a lot of rollups have been rising. Ethereum has changed its roadmap to a rollup centric roadmap, right? It's now started to cater to a rollup centric roadmap. We've seen things like DAG sharding, proto-DAG sharding that happened like a few months back, and this proto-DAG sharding is like a precursor to what we call DAG sharding itself. Which is a way to improve data availability for the Ethereum consensus layer. And why they decided to do that is because we realized that DA was one of the biggest bottlenecks to roll-up scalability, right? It was not execution. Execution is there, but it is not the only bottleneck. The biggest bottleneck was the base layer was not able to handle the DA that came out as a result of all of these executions that was happening, right? So DA was being solved, Avail did solve it, and because of that, hundreds of general purpose rollups, application specific rollups, software rollups were all being expected, are appearing out of the air today, right? It's very easy to start running a chain of your own today, and this is leading to a fragmentation of UX, liquidity as well as developer experience, and we need a way to basically interoperate in a trust minimized way. Here the keyword being trust minimized, right? And because we need to interoperate in trust minimized way, we also need to have a way to share economic security across ecosystems, because if we are unifying several ecosystems, we need to be able to share crypto economic security between those ecosystems. And basically that is what Avail kind of brings into. The unification layer itself consists of three things on our roadmap, right? So the first thing that Avail is probably the most known for is Avail DA, which is a data availability focused layer that we've been building, and mainnet is around the corner. The next thing that I will be focusing on for this talk today is going to be Avail Nexus, which is a permissionless verification hub that will unify rollups and chains, and basically it's going to be a way for coordinating execution among different rollups in the ecosystem, allowing you to have what you call as chain layer abstraction that even Gyan had talked about the cake framework and all of that. So that is the layer at which we are working at, and then to bring it all together, like I said, we need a shared layer of crypto economic security. That is what Avail Fusion provides, wherein in simple words it allows you to bring in and stake tokens of different ecosystems. Like for example, you can stake your Bitcoin or Ether or any other token to be a part of the consensus of Avail, right? You can use your tokens to secure the Avail consensus, because why? At the end of the day, Nexus is being built on Avail DA, and Avail DA would eventually be responsible for coordinating execution across different rollups. It will be unifying the different ecosystems, and as we unify these different ecosystems, we need a way to unify crypto economic security across those ecosystems, and that's what we're doing with Avail Fusion. So today, I'll be talking about Avail Nexus, which is better UX for all, as I like to call it, right? So essentially, let's look at how things work in Web 2 today, right? So imagine you go to like your favorite marketplace, like Amazon, for example, right? You go to the website, you find something that you like, and you click buy, right? And so when you click buy, what happens is they send you to, they redirect you to a payment provider like PayPal or whatever, Razor Pay or something like that. And what you do is you put in your payment details. And what PayPal does behind the scenes, it communicates with your card, and like if you're putting in a credit card or something like that, it talks to the Visa network or the MasterCard network, and basically what happens is, you can switch and play with whatever network you're playing, that you're using, or you're a customer of, and all of this is happening behind the scenes. But what you are doing is, you are just clicking buy, and you're just putting your payment details. Behind the scenes, the verification, the authentication, everything is happening, and at the end of the day, your order is delivered, right? So, how does it work in Web3 today is, you have a multi-step process. First step, you are on your source chain, you need to go to your destination chain. For that, you have to first take your token, lock it on a bridge, mint that token on your destination chain, do whatever you want to do. At the end of the day, you want to get out of that chain, you have to burn those tokens, unlock it on the other side. This is already 4 steps out of the first step, right? And then this is the next big thing. Imagine you're probably already using at least 2 to 3 chains if you're an active user of the Web3 community, or even more. And these are probably, just consider this as different interactions happening between these chains, and all of these arrows that you see. Remember I said we were using bridges and that 4-step process? This is that across 4 chains, right? So imagine that across 4 chains, and now imagine that across n number of chains, right? This is not it. This is not how we want Web3 UX to be like. So how do we simplify this? So this is how easy it could be, right? So just imagine the chain 1, 2, 3, 4, whatever it is. It interacts with what you call as nexus, or basically it's just considered as a middleware, right? And the magic about this is that in the previous image that I showed, all these different bridges interact with different lifelines of the different chains as well. These people have to run the full nodes, they have to have assumptions of the lifelines, all of these things for each and different chain in each and every different ecosystem. But for Avail, once you're connected with Nexus, you just have to run the Avail lifeline, and you're able to verify and validate the execution across all the chains in that ecosystem that are connected to the Nexus protocol, right? So just you remember the earlier image. Now imagine that all of them just talk to the Nexus, and Nexus does all of the coordination across all of the chains for you. So, like I talked about the Amazon example, let's just imagine, right, 2 highly specialized chains. Just consider them as application-specific chains. They just do one single thing, right? One chain just tracks NFTs, and who owns them? It does not have any other asset on that. You cannot do any ERC20 transactions, only ERC721. Just think of that, right? And then you have another chain that just does ERC20 transactions. You cannot do anything else, right? Now, how do you do an NFT trade on such an architecture, right? On a traditional architecture, it's bad, but how do we want it to happen, in an ideal world? So first you go to this marketplace, you see an NFT you like, you hit, buy. When you click buy, you are directed to a payment provider page, and this can be facilitated by a wallet, or it can be done by the marketplace itself, whatever you want. You click buy, and done. Once the payment goes through, your NFT is transferred to you. How do we do that, right? So again, similar process. Just imagine now you have Nexus in between. Now imagine, so remember the previous image that I said, right? You don't have to go through the entire bridging process. You just need to be connected to the Avail Nexus. And if you're on OpenSea, for example, the NFT marketplace, what you just do is you click buy, Avail Nexus does everything for you that coordinates with the payment chain. This can be like zk sync, for example, you just have funds on a zk sync chain. but your NFTs run OpenStack chain, or maybe your funds on Arbitrum chain, or a Polygon CDK chain. Whatever it is, it doesn't matter, right? And that is the kind of thing that we kind of provide. So how does Nexus interoperability work actually, like from a user perspective? Basically, when you're on that NFT chain, you're on that NFT marketplace, you are clicking, like you want to buy that NFT. So what happens is, you are basically reserving that NFT, and that NFT is basically placed on a hold, right? It's basically changing its status from like open to pending. And what happens is now is that that updated state is sent to the Nexus through the state transition functions, and a proof is being sent, and the state root is also being sent to the Nexus. And now you make the payment on the payment chain, right? The payment chain now creates a payment inclusion proof to the Nexus, and the NFT chain can pick that up from the Nexus. And so if the payment inclusion proof is valid, it confirms the NFT transfer. If there's a non-inclusion proof, there is also a way to do a non-inclusion proof of that. And if there's a non-inclusion proof, you cancel the NFT transaction, right? So it's pretty much like a Web2 experience that you get. And this is what we call as asynchronous composability, which is the main feature that we want to bring through the Avail Nexus. Just to talk about how this actually works, like, and why does it work? Because when a blockchain wants to talk from one chain to another chain, there are basically just two questions that you need to answer. One is, what is the canonical and the final order of the chain? This is important because without that order of the chain, you cannot actually do any meaningful transaction, right? And second, even if you have the canonical order, you need to make sure that whatever transactions you have, are those executions valid? If you have the answer to these two questions, you're able to communicate with any chain in an ecosystem. So, and through Avail Nexus, the main idea is not to do anything fancy, but the idea is that we know that each roller have their own specific state transition functions. We don't care, or we don't want to know what those state transition functions are, right? We just want to know that are those executions done faithfully and correctly, right? Because you might have a Move VM, you might have a Solana VM, you might have an EVM, whatever it is, or an application-specific VM, and then the validation of those executions can also be different. Like if you have a ZK rollup, for example, you might also use different kind of proof systems. So all of this comes together, right? You have rollup A, rollup B, rollup C. They might have different state transition function proofs, and they connect to the Nexus adapter, and an aggregated proof is created through the Avail Nexus, which you can verify. Which you can basically verify by, like, basically if you can verify through that one single proof the execution validity of all of the rollups in that that are connected through Nexus, right? So this is basically what I just explained here. So by verifying a single proof, you could essentially verify the validity of all executions that could be ever relevant to that particular chain that you're on. That is game changing, and Avail Nexus is the verification hub that enables that for you. So yeah, so basically this is again a simplification of what I just talked about. You have all of these different chains, you have the Nexus adapter, it creates an aggregated proof, and here's the catch. You can all of this can be verified by a light client. You don't have to run a full node, you don't have to run any fancy infrastructure. It can just run on your phone or a very light device. It doesn't take a lot of space or energy or resources. And in the same way, so you have Nexus, you also have DA. So if your chain is using Avail DA, you can also get DA guarantees on top of that, which again the light clients do data availability sampling and verify the DA guarantees as well. So you get two-in-one things, right? So basically, Avail can kind of handle the coordination of execution verified by light client. You have data availability verified by light client, and this is kind of game changing because we're now unifying different ecosystems together. Yeah. Yeah, so you might have already seen this kind of diagram all over CTO. You have the monolithic architecture, you have the modular architecture. Basically, modular is basically the decoupling of execution from consensus and data availability. And I spoke about in the previous picture how we are kind of unifying that through this. So like in the modular structure as well, if you want to build an application, if you want to run an app chain, you want to communicate with different chains, you need to be running a full node across all of these chains, which is the hard part. But with Avail, what you can do here is, because even in this modular architecture with n number of chains, you're all being unified by Avail DA and Nexus, which means unified user experience and developer experience, because now you don't have to worry about working with different bridges. You just have to work with Avail Nexus and the Nexus adapter, and all of that is verified and can be run with the light client, right? So all of the verification can be done with the light client, DA and execution guarantees. So yeah, so basically your one chain through the Avail light client is able to access a plethora of multiple rollups with the Nexus itself. And yeah, like how easy is it to run a light client? You can, if you want to, you can just put in this command shell and it will just run. And right now it is just the DA light client, but when you do actually release Nexus, Nexus is still like in its POC. We'll release it at the end of the year, but it will be ready soon. Basically, just sucking it up. This is how cross-chain interoperability is today. This is how simple it can be. And yeah, and by being connected to Nexus, you get access to a plethora of chains within the ecosystem. And basically, Avail accelerates the unification of Web3 by enabling modular execution layers, like I mentioned before, to scale and interoperate, and with the keyword being in a trust minimized way, because you're using light clients, and your light clients, which can run on any device that you want, can verify both the proof guarantees and the DA guarantees. You're doing it in a trust minimized way, which is something that is not possible, as far as I believe, in any other protocol out there. So yeah, that's pretty much it. Any questions so far?
Guys, if you have any questions, I will let Robin take it offline as well. I know we're running short on time. Thank you so much, Robin, for all the efforts. Next up, we have Asad from Octo. We had Yash before speaking about the product side of things. Asad is a chain architect at Octo, and he will be giving just the brief rundown on what the Octo chain does and the architecture as well. Please take it away.
Awesome. So I think the fundamental of this entire conference so far has been, as chain abstraction, where can we go, what can we simplify in general. But for the past 2 years in Octo, we have been trying to solve chain abstraction before it was even a word. For us, we view chain abstraction from a different lens. For us, it's basically mass adoption. How can we enable blockchain use cases across different Web2 applications and across different partners that they want to use, but they may not have the capability to learn the entire blockchain as a whole as of today.